Good evening. In today's session, we will have a look at how the arithmetic mean gets calculated in a continuous series in an Excel worksheet. If you have a look at the worksheet, you will find that the data set has been put in the form of a class interval along with the frequency column. So it is x and f which is given to you, and this x is given in the form of a class interval. Now, if you will try to put the information in the form of a class interval in an Excel, let's say if I would like to put in it as from 10 to 20, you and press enter, you will find that it doesn't take the information in that same format. So how we are going to form the class interval here? The formation of the class interval will be done by the use of a particular method. And the simplest way to form the class interval or to put down the class interval in an Excel is going to be that you first of all list down the lowest or the lower limit of the class interval. Let's say I pick up 10 and then I write 20. So I pick up two lowest values or lowest limit of the class interval. One is 10 and the other one is 20, and for the remaining one I simply drag the cursor. So I simply drag the mouse, and in this way I would be forming a I'll be putting the lower limit values of the class interval. Same fashion I will end up putting the upper limit values of the class interval. So what I end up doing here is I simply take 20 and 30 only of the first two class. I write on the upper limit value, and then I end up dragging the rest of the ones to get formed. So 20 and 30, and you place the mouse there and then simply drag so as to get other values of the class interval. So just because I happen to show to you that if I'll try to key in 10-20, it will not take the information as such. It will be putting it in a different format, and how this class interval can be put or formed in the Excel sheet, how we are going to create it, that creation part is getting explained by me here. So as I said, first I'll take up the first two lower limit values and simply write down the lower limit values. And in the remaining, for the remaining lower limit values, I'll simply drag the cursor down. And then in the next column, I'll simply put the upper limit values, the first two upper limit values, and then place the cursor and drag the mouse down. Now, how I'm going to form this class interval and put them together? What I'll do is, I'll first of all press the equal button, and then I will write CONCA. So once I write or type CONCA, you will find that two of the options gets opened. I'll click on the second one. I'll place a click on the second one, and this is what is called as concatenate. Right? So concatenate, this is what it is pronounced as. So this concatenate will be helping me to form the class interval. So what I end up doing here is I press equal button, then I write CONCA, and then once I just simply write CONCA, I'll find that it will open two options for me. I'll press the second option, and then this way concatenate will get opened for me. Automatically you have this opening bracket. Fine, so I have the opening bracket with myself, and then what I end up doing is I click on 10 because 10 is the lower limit. So I'll click on 10, and then I'll put a this thing comma. So after clicking on 10, I'll place a comma. Then please pay attention, without giving a gap. What I'm going to do is I'm going to use inverted commas. So double inverted comma will be getting used, and then place a hyphen. Again, I'll close this by putting the inverted commas. So the hyphen will go in double inverted commas, and then I'll place a comma. So after placing a comma, what I'll end up doing is I'll select 20. Fine, and then close the bracket. So after this, I press enter, and in this way 10 and 20 will come together. Once again, we can have a look at how the class interval is formed here. I press equal sign, then I write concate, and this concate opens two things for me. I go with the second one, concatenate, and once I open up the concatenate, I end up getting a opening bracket. In the opening bracket, it is asking me to put a value. I click on 10 because that's the lower limit. After this, I put comma. Then I go for the inverted commas. Inverted comma is there, and then I place hyphen. I close the entire thing, and then again I place a comma. Once I place the comma, I simply click on 20, and after this I'll close the bracket. So you will find that the lower limit is getting represented by L4, your hyphen or that interval range is getting shown in the form of inverted commas, fine. So the double quote is there in which this hyphen is placed in, and then I place a comma and then I choose the upper limit value, and then I close the bracket and press enter. The moment I click on enter, here I have 10 and 20 getting put in the form of a class interval. Once I have used the formula, I'll simply drag, I'll stretch the mouse, and in this way, the class interval can be written in an Excel sheet. So that's how the class interval has come in here. Now, in our continuous series, we know that yes, we have the class interval and the frequencies corresponding to those class interval. What we will end up doing is now this class interval has to be put in a discrete form. Since there is no specific value here, we have a range of values starting from 10 to 20. As already explained in my previous videos, at the time of counting, we will count from 10 to 19 and 20 will get added in the next class. So you can refer to those videos for the understanding. But for the moment, I bring you back, this class interval has to be converted into a specific value or in a discrete form. And how do I end up doing this? I simply take up the lower limit value and add up with the upper limit value. So 10 plus 20 divided by 2, it gives me 15. So if you want, you can do it manually, or if you want, you can kind of go with the Excel function. If I would like to add, what I'm going to do in here is equal sign. I place equal sign. I select 10 and then I press the plus button, then I select 20 and then press enter. So this gives me 30. So right now what I have done is I've simply added the lower limit and the upper limit, and it gives me a sum total of the two. So once I have this one with myself, I'll move on to the second one. Again, I select 20 and then press plus and then press the upper limit value. It gives me 50. Once I have two with myself, I'll simply stretch and drag the cursor, and in this way, I'll have a sum total of the lower limit and the upper limit. As I'm looking out for a midpoint, a specific discrete value. So the formula to find the midpoint is lower limit plus upper limit divided by 2. If I could have wanted, I could have done this entire thing here itself. I could have divided it by 2, but I prefer not to do so and I keep it simple for myself. So I select 30 here and I divide it by 2 and press enter. So this gives me 15. Now if I drag the mouse, I'll get the other midpoints as well. So this is how the midpoints get calculated in the Excel sheet. So keeping my work easier, making my work easier, I've already kind of listed down the lower value and the upper value in two separate columns. Since I have put them in two separate columns and to distinguish them from the others, here it gets shown to us that I have listed down in the other two columns. So here is the lower limit and the upper limit. How the class interval can be formed from these lower limit and upper limit values, that formula has been explained by me to you. And then the same values or the same columns can be used to find the sum total, and from the sum total we find out the midpoints. So it is a sum total of the lower limit and the upper limit value, and you divide it by 2 and you get the midpoints. Once we have the midpoint with our cells, we'll put it down here in the column. And then it's, if you're using the direct method, it's a straight and simple case. You end up multiplying the midpoints with their respective frequencies so as to have them together. The insertion of the formula has already been explained to me by me in discrete and in individual series. So you can refer to that area again. So you simply go to insert and you move on to symbols from where you can get all these symbols for your formula. So as the requirement of the formula is, it says under the direct method, X bar, that is our average, is a sum total of the midpoints, the product of the midpoints with their respective frequencies divided by the sum total of frequency. So this is what we end up doing here. We simply multiply the midpoints with their respective frequencies or with their corresponding frequencies, and this gives me a column of FM. After this, I take a sum total of the FM column and I simply select all of them and I press the sigma button, which gives me 3990 as the sum total of the product of the midpoints with their frequencies. Then I divide it by the sum total of the frequency, and here I get the average, which is 66.5. So this is how the working is done in an Excel sheet. Fine. Now we can continue with the calculation of arithmetic mean in a continuous series by using the shortcut method. So if I talk about the calculation of arithmetic mean in a continuous series by using the shortcut method, like if we have a look at the formula just we happen to deal with just now in the Excel sheet, that was a direct one where you had a sum total of the midpoints with their respective frequencies divided by the sum total of frequency. Shortcut method would be involving one more step ahead. In the shortcut method, what we are going to do is from the midpoints, how did we get the midpoints? We converted the class interval into a discrete form. So the continuous got changed into a discrete form by finding out the midpoints. And from the midpoint now, what we are going to do is we'll assume a particular value as mean. So let's say we assume 55 as to be the mean. So here what you are doing is you are applying a shortcut method of finding out the mean, and to find the mean you are assuming a particular value as mean from the midpoints. Remember, the mean is always assumed from your midpoints or from the values of the variable. It is never from the frequency, because frequency only tells you about the number of times that value is repeating itself or the number of times that particular value is occurring. So the occurrence is mentioned by the frequency. So the assumption of the mean is always done from the midpoint. So let's say in our case, we are assuming 55 as to be the midpoint as the mean. Now, what we are going to do is we'll find out D. D stands for deviation, and what D is going to be, how it is going to be done here. 15 minus 55. 25 minus 55, 35 minus 55, 45 minus 55, and the value subtracted from itself will be equal to 0. So this is how what we are going to do. We'll be finding out the D. D stands for the deviation. Deviation of the values of the midpoints taken from the assumed mean. And this will give us the deviation column or the D column. Once we have the deviation of the midpoints from the assumed mean, the next step is going to be that we will be putting this D along with F. Now, how do we know that we have to put D along with F? Just because that's the requirement of the formula to find out the average. And the formula here goes as A plus summation, sum total of the product of the two f and d divided by the sum total of the frequency. Here A stands for the assumed mean, which we have as 55 in this case. Sum total of the product of the deviations with their respective frequency. Yes, of course, we multiply the deviations with the respective frequency, and this gives us the FD column. We take up the sum total of the FD column, which comes out to be 690, and we divide it by the sum total of the frequency, which is 60. So 690 divided by 60 gives us 11.5, and this 11.5 gets added to the assumed mean, that is A, to give us the average. So that is how the mean gets calculated in a continuous series by using the shortcut method. You must have kind of seen that whether you use the direct method or the shortcut method or the next method which I am going to take up, step deviation method, any of the methods used to find mean in a continuous series will be giving you the same answer. Proceeding further, let's take up the calculation of arithmetic mean by using the step deviation method in a continuous series. So in the step deviation method, from the word itself, you will understand that one more step has to be taken after the deviation. So you have already formed a D column. We got the D column by subtracting or deviating all the midpoints from the assumed mean. Remember, in statistics, it is always preferable to use your deviation rather than using subtract. So it is like we are taking the deviations of the midpoints from the assumed mean. So m minus a 15 minus 55, that's how we had the D column, which has already been explained. After getting the D column, we take one more step ahead. And what is that one more step ahead? That one more step ahead is that if I would like to simplify my calculation or my figures here, and how I can simplify my figures here, I find that something is common here, and that commonness is in terms of the interval. So since there is an interval of 10, if I divide all these deviations by 10, I will get D dash columns. So I take one more step to simplify my values or to simplify my figures. And how do I take that step? I take that step by dividing the deviations with the class interval. So either you can divide the deviation with the class interval, or you can divide the deviation with a common factor that you come across in these midpoints. If you have a look, it's not only an interval of 10 which is common to them, but then all these midpoints, they have 5 at the back, which means they are all divisible by 5. So if I want, I can find the D dash by dividing the deviations with 5. So either I divide D with the class interval, or I divide D with the common factor or with a common value, which comes out to be 5 here. But then for the present case, what I'm doing is I'm using the class interval. So I'm dividing here it by the class interval. And here what I have done is it simplifies the work in a way. All the zeros are done away with. And here I'm left with the single digits. After this, once I have taken one more step of kind of making my deviation work easier for me, after finding the deviation, I have taken one more step of finding D dash. I go back and have a look at the formula, and I realize that the formula has changed slightly here now. Assumed mean plus sum total of the deviation, that step deviation that I've taken, D dash. So the D dash multiplied with their respective frequencies as sum total of it, divided by the sum total of frequency into I. As in D dash, I have divided the deviations with the class interval. In my final formula, I'll again take it back to the same position and I'll multiply it. So that interval which was kind of used for division purpose will be in the final formula, will be going as in the form of multiplication. So multiplying it with the class interval. Now keep it in mind when you are doing the calculation, you will follow the BODMAS. Fine. So bracket of division, multiplication, addition and subtraction. All these steps have to be kept in mind. So what I end up doing here now, I take up the sum total of the FD dash, which I have with myself, the D dash getting multiplied with their respective frequencies. So the D dash getting multiplied with their respective frequencies and taking a sum total gives me a sum total of 69. 69 divided by 60. After I have done it, I get 1.15. I multiply this 1.15 by 10 because that's the interval. As I said, follow BODMAS. First comes the division and then the multiplication. Once I multiply, it becomes 11.5. I add up this 11.5 to my 55 and this gives me an average of 66.5. So no matter you may follow any of the formula, you will find that the answer or the average with you remains the same. Enough for the day today. Thank you so much.